Hi, today we are going to discuss how to graph quadratic functions. This is discussion of just the basics of that. We're going to start by looking at this function f of x equals x squared. We are going to start by making a table of values. I already pre-selected the values of x. So what we do is we take each value of x, substitute it into the function. So we do negative 3 squared, which is 9, negative 2 squared, that's 4, negative 1 squared, that's 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. We have 7 points. Negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And you can see that the points that we plotted are kind of shaping a curve. So if we connect them, we are going to get a graph that's going to look like this. This graph has a special name. It is called a parabola, right here. So what do we need to know about this graph? This graph opens up, as you can see. It has a minimum because it's going to have the lowest point right there at this point, which is called the vertex. So it has a minimum. A vertex is going to be at 0, 0 at the origin. We have something that's called the axis of symmetry. This graph is symmetric. So right there is a line which is actually the axis of symmetry of that graph, which is going to be the y-axis that has an equation x equals 0. And this graph is also going to have its its y-intercept. Well, it's also the x-intercept in this case, 0, 0. So let's talk about some of the basics of quadratic functions that we need to know. We have something that's called standard form of a quadratic equation, f of x equals ax squared plus bx plus c. We do have a restriction, a cannot equal 0. If a is 0, it's going to cancel the quadratic term and you no longer have a quadratic function. So a cannot be 0, but b and c can be absolutely anything. What else do we need to know? If a is positive, so if the number in front of x squared is positive, the function is going to open up, or we say concave up, and it's going to have a minimum. If a is negative, the function is going to open down, we say concave down, and it's going to have a maximum. Whether you have a minimum or maximum, it's always going to be located at the vertex. So vertex is a very important point. So how do we find the vertex? There's a formula you need to remember. X equals negative b over 2a. Those are the numbers that you're going to pull from the function. This formula here will also give you the equation for the axis of symmetry. And once you find the x-coordinate, you will substitute that x-coordinate into your function to get the y-coordinate. Let me show you a couple of examples. Find the vertex and then determine the minimum and maximum. So we are going to take this. I always recommend to students identify A, B, and C. You don't really need C, but A and B for sure. A is the number in front of x squared, that's 2. B is the number in front of x, which is negative 4, and C is 4. So x equals what? X equals negative. B is negative 4 over 2a. Please be very careful. A very common mistake is messing up with the negative signs, forgetting them, putting too many or anything like that. There is a negative that comes from the formula. I have another negative because that's the value of b. So what do we have here? Negative and negative will make it positive. 4 divided by 4, you're actually going to get 1. So that's the x-coordinate. To find the y-coordinate, you need to do f of 1, so we're going to take this value, 2 times 1 squared minus 4 times 1 plus 4. You always follow the order of operations. So it's going to be 2 times, that's 1 squared is 1, times 2 is 2. 4 times 1 is 4, so minus 4 plus 4, and we can have 2. So, and this parabola opens up because this is positive, so it opens up, which means we're going to have a minimum. So our minimum is going to be at the vertex, which is 1, 2. And that's also our vertex. Let's take a look at this one. So a is the number in front of x squared, which is negative 3. b is the number in front of x, which is negative 12, and c is negative 5. So we are going to use the same formula, x equals negative b over 2a. So negative b is negative 12 over 2 times negative 3, which is the value of a. So negative times negative is going to make it positive. So I can write positive 12 on top. 2 times negative 3 on the bottom gives you negative 6. 12 divided by negative 6 is negative 2. This is the x-coordinate. So now we need to find f of negative 2, which is 2 times negative 2 squared minus 4 times negative 2 plus 4. So let's see, that's 4. 2 times 4 is 8. Negative 4 times negative 2 is plus 8, and plus 4. I'm sorry, I was looking at the wrong equation. My apologies. Let me try it again. Negative 3, I was looking at the equation from the first one. Negative 3 times negative 2 squared minus 12 times negative 2 minus 5. Ignore that. Everybody makes a mistake. Negative 2 squared is 4, so it's negative 12. Negative 12 times negative 2 is plus 24, and then minus 5. So all this will give us negative 12 plus 24 is 12, 12 minus 5 is 7. So in this case, this parabola, so this value of a is negative, this one's going to open down, which means we're going to have a maximum. Alright, so we have a maximum, which is actually going to be our vertex. It's going to be negative 2, 7. Okay, we have one more problem that we are going to do that actually is going to be where we're going to graph the whole thing. Alright, so let's take a look at this. Graph the function f of x equals 2x squared plus 8x plus 1. Find its y-intercept and an equation for its axis of symmetry. So first of all, a positive value of a right there, which means it's going to open up, and we're going to have a minimum. We're going to need to find what it is, but we're going to get to it. You can't, as you can see, my table does not have any values here because I do need to know where my vertex is first. So what I'm going to do is I'm going to find the vertex. So let's start by finding the x-coordinate. X equals negative b over 2a. That's that magic formula. So in our case, it's going to be negative. The value of b is 8. The value of a is 2. It's going to give us negative 8 divided by 4 is 2. Right? So now we need to find the value of y. 2 times negative 2 squared plus 8 times negative 2 plus 1. 2 squared is 4 times 2 is 8. 8 times negative 2 is minus 16 and plus 1. So 8 minus 16 is negative 8. Negative 8 plus 1 is negative 7. So our vertex is negative 2, negative 7. We can write it here. So what was the reason for us to find the vertex first before we make a table of values? We need to go, because that's kind of like our center value, and we're going to pick points to the left and to the right of negative 2. Also, there is axis of symmetry which is going to pass through that point. If you look at the earlier part of the video, you have axis of symmetry here, which is going to be x equals negative 2, that same value. So our axis of symmetry here is a vertical line x equals negative 2. We're going to get to the y-intercept in a moment. So what I'm going to do now is I'm going to put negative 2 in the middle. I'm going to leave 3 spaces on one side, 3 on the other side. So I'm going to pick 3 numbers to the left of negative 2. That's negative 3, negative 4, and negative 5. And 3 numbers to the right. That's negative 1, 0, and 1. We already know that at negative 2 the value is negative 7. So what you need to do now is take each value, substitute this into the function, and calculate its respective y value, which is f of x. Let's start with positive numbers. So here we're going to do 2 times 1 squared plus 8 times 1 plus 1. That's 2 plus 8 plus 1, that's 11. 0 is going to be 2 times 0 squared plus 8 times 0 plus 1. That's going to give you 1. Negative 1, 2 times negative 1 squared plus 8 times negative 1 plus 1. What does that give us? It's going to give us 2 times, negative 1 squared is 1. 2 minus 8. 2 minus 8 is negative 6 plus 1 is negative 5. We already know that. Negative 3. 2 times negative 3 squared plus 8 times negative 3 plus 1. Negative 3 squared is 9. So it's 18 minus 24 plus 1. 18 minus 24 is negative 6 plus 1 is negative 5. And you probably remember what I mentioned earlier about symmetry. This is the center. So the values you can see they're the same. You are actually going to end up getting 1 here, and you're also going to end up getting 11 there. Alright, so let's plot the points. Oh, by the way, 0, 1, this is our y-intercept. We're going to list this here. To find the y-intercept, you always make x equals 0, whether or not we actually had this value here or not. So negative 5, 11, 11 is kind of right there. Negative 4, 1. Negative 3, negative 5. Negative 2 is negative 7. Negative 1 is negative 5. 0, 1. And 1, 11. And we connect them very carefully. We do need to make sure it's nice and smooth. And there is our graph. Okay. So hope you see it's not that difficult to do. Hope this helps.